Welcome to this GCSE chemistry presentation on the rate and extent of chemical change. In this chapter, we'll explore how reactions happen, what affects their speed, and how changes in conditions affect equilibrium. To calculate the rate of a chemical reaction, we divide the amount of reactant used or product formed by the time taken. Reactions are often shown on a graph. Steeper lines mean faster reactions. According to collision theory, particles must collide with enough energy to react. This minimum energy is called the activation energy. Increasing collisions or energy increases the reaction rate. Several factors affect how fast a reaction occurs: temperature, concentration or pressure, surface area of solids, and the use of catalysts. Let's explore each. Decreasing the particle size of a reactant increases its surface area. This exposes more particles to potential collisions, which increases the frequency of successful collisions and results in a faster rate of reaction. If you increase the concentration of reactants, the system makes more products. Removing products also shifts the reaction to produce more. Increasing temperature favors the endothermic direction. Decreasing it favors the exothermic one. This shift helps absorb or release the extra heat. Catalysts speed up reactions without being used up. They work by lowering the activation energy needed. In biology, enzymes act as natural catalysts. Experiments rely on tracking mass, gas volume, color changes, or precipitates. These data are used to calculate average speeds, initial reaction rates, and specific reaction orders. A steeper gradient means a faster rate. The curve flattens when a reactant is fully consumed. The final amount of product is the same, only the speed differs. Some reactions are reversible, meaning the products can reform the reactants. These are shown with a double arrow, like ammonium chloride decomposing into ammonia and hydrogen chloride. In reversible reactions, one direction is exothermic and the other is endothermic. The energy released in one direction is equal to the energy absorbed in the reverse. Equilibrium happens in reversible reactions when the rate of the forward reaction equals the rate of the reverse. This only occurs in closed systems where no substances escape. Le Chatelier's principle states that if you change the conditions of a reaction at equilibrium, the system will adjust to oppose the change. If you increase the concentration of reactants, the system makes more products. Removing products also shifts the reaction to produce more. Increasing temperature favors the endothermic direction. Decreasing it favors the exothermic one. This shift helps absorb or release the extra heat. For reactions involving gases, increasing pressure shifts equilibrium toward the side with fewer gas molecules. Decreasing pressure does the opposite. To sum up, reaction rates depend on particle collisions and conditions. Reversible reactions reach equilibrium, and changes in conditions affect the direction of reaction. Thank you for watching, and please subscribe to my channel.